and 7.2.
Okay, hold on, let me look. Okay, does that look better?
Yeah.
Yeah.
Okay. Okay, cool. All right, so this thing is 12 pages long, so I don't know how long it's going to take us to get over it. Could be a couple days, could be the whole week. I don't know. Depends how many questions you have, and that's okay too. So there's no rush. We'll see where we get to. Hopefully we can finish it by the end of the week though. So let's just start at the beginning and see where we go. So for part A, it says to find G of 5. So I believe we did this problem last class or something very similar. So G of 5 would be plugging 5 into that top bound, at which case now you're looking for, it says G equals integral F. So from -3 to 5 is just the area of these two triangles on the top. So for part A, your answer is going to end up being 16. And then to get your full credit, again, you want to write everything out. So for part A, you want to say that G of 5 is equal to -3, plug in your top bound now for 5 of f of t dt. And you can just go right after that and say it's equal to 16, and you're done. Okay. Any questions on A? Okay, on B, we're looking for increasing, which is going to be above, and concave down, which is a negative slope. It's important that we note that they're asking us these things about G. So the first thing we want to make a note of is that G prime is equal to F. So if we know that G prime is the same thing as F, you can say that we're looking at the graph of F, but it's also the graph of G prime. So that if they ask me things about G prime, I can treat this as the derivative of G to figure out my information. So we're looking for things that are above the x-axis and decreasing in their slope. So the answer to this question would be from 0 to 5. You should be familiar with how to write that out now. And the two keywords you need are positive and decreasing. Okay. Any questions on part B? Okay, part C, similar question. They want to know a relative max. The relative max would be at x equals 5. And again, we're going to lead with the same thing. It's helpful to know that G prime is equal to F. So there's a relative max at x equals 5 because G prime changes from positive to negative is the key justification you want there. Positive to negative, and it's a relative max at x equals 5. Okay. And for the last one, part D, that's the one where we do the quotient rule. And again, I think we did this whole question already earlier in a previous session. So this should be familiar to you guys. You're going to do a quotient rule for this one. So when you do that, it's going to be bottom. Let's start with h prime. H prime of x is equal to bottom, derive the top, minus the top, derive the bottom over the bottom squared. And then into that, we got to plug in a 5. So you've got 15. G prime is equal to F. So G prime of 5 is the same thing as F of 5, which is 0. G of 5 we found in part A, and that was 16. If we put this into the bottom, that's going to be 15 squared. And remember, we said you can just stop right there. Okay. So if you did more math, that's fine. This right here is also acceptable, saying that H prime of 5 is equal to that. Okay. Any questions, guys, on first page, the free response? All right, moving along. That takes us to, hold on, is there something in chat? Okay. All right, next page. Okay, similar kind of question. We've got in this problem, it says that we have the graph of F. You're hopefully starting to see that as you do calculus problems, it's really important to always identify what graph do we have. So it's the graph of F. When your integral matches the graph, integral of F, graph of F. Those are the same thing. You're finding area, you're finding geometry shapes. So for part A, it's just asking you to find the area of the graph that I see from -3 to 6. So at the top part of that graph from -3 to 5, that's going to be 32. And then this one over here is a 1/3, definitely not drawn to scale. That's going to be what? -3/2. So the top part is 16, and then the bottom one is 3/2. And then if you put all that together, I'm coming up with 14.5. 29/2 means the same thing. So you want to say that the integral from -3 to 6 of f of x dx is equal to, you could go 14.5. Again, you could go 29/2, same thing. Okay.
Can you just leave it as 16 minus 3/2?
Yes, if it's free response. Quite likely this particular question is going to be multiple choice, to be honest. Part B. Okay, this one's different now. It's the integral of f prime. I have the graph of f. These don't match up, so it's a different question. However, if you integrate f prime, this is a fundamental theorem question. This is FTC. If I integrate f prime, I'm going to get f. F of what? F of 0 minus f of -3. Can I find f of 0? Can I find f of -3? Sure. Look at the graph, because we have the graph of f. The graph of f is up there. F of 0 is 4. F of -3 is 0. Answer would be 4. So again, this integral is f prime. So if you integrate f prime, you get f, top minus bottom. F is 0. Look at the graph. That's 4. F of -3, that's going to be 0. And then you can see how that checks out to be 4. Okay. And then part C. Part C says, all right, this is new. Like a lot of these problems, not a lot, but sometimes there's going to be stuff to learn on the fly. Okay, what do we know? What do you notice about this problem that's different than normal problems?
The higher numbers on the bottom rather than the top.
Yeah, exactly. So we always want the big bound is on the top. And there's a little rule with integrals that says the following. So this is new information. You can put a negative sign in front of your integral. And if you put a negative sign in front of your integral, you can then flip the bounds. So if your bounds are not in the order you want, a negative sign in front of them flips the symbols. So we toss a negative symbol in front, and now we're ready to go. I want the area from -3 to 5 of which graph? F. The graph I have is F. So that's going to be 16, but with a negative sign in front of it. So I'm coming up with -16. Okay. Does anybody have any questions on that page? Okay. All right, next up. So we're going back into dy dx, old problem. So hopefully this wasn't too terrible for you. So for part A, we want to find dy dx. So it's going to be 6y squared dy dx minus, I'm going to put a bracket up there because we have a product rule. So it's going to be first derive the second plus the second, and then derive the first. We should have done enough of those that makes sense now to just slide the 2 out front. It's equal to 0. Doing a little bit of combining now. This is 6y squared dy dx. Distribute the minus sign. Minus 2x dy dx minus 2y is equal to 0. Okay, dy dx to stay on the left. The 2y heads to the right. So I'm just going to scratch that out to save some time and toss a 2y over there. And we need to divide by the quantities. So dy dx is equal to.
Mr. Baker,
Yes.
isn't it just 6y?
Did I screw up? 6. Oh, you're right. Thanks. So it's going to be 2y divided by 6y minus 2x. Is that what you guys got?
Yep.
Okay. All right. Any questions on part A? That would get you full credit. Okay. For part B, just remember this is our dy dx in part A. So for part B, we want a tangent line. To write the equation of a tangent line, we should make a box. And in that box, I want a point. I want a slope. They give me the point, 25, 10. To find the slope, we go to our derivative, which is what you found in part A, and you plug in the point. So if we plug in 10 for y, that's going to be 20 over 60 minus 50, 20 over 10. I'm coming up with 2 for a slope. Now, if this was to be free response, you got to write the equation out. You can't just leave it as a box. So this is going to be the equation of that tangent line would be y minus 10 is equal to 2 times x minus 25. Okay. Any questions on B?
Could you show A again? I just think like the screen is kind of small.
Good?
Yep.
Okay. And takes me to part C. Okay, what are we being asked to find? We're being asked to find a second derivative, which means we want to take the derivative of the derivative. So it's going to be bottom, derive the top is 2 dy dx. Bottom derive the top minus the top, derive the bottom. Derive the bottom is 6 dy dx minus 2. Bottom derive the top minus the top derive the bottom over the bottom squared. Okay. All right. So we got a second derivative. And into that, you're being asked to plug in 25, 10, which should sound familiar. That was the point they asked for in part B. So we start to plug that in. And if you do that, it's going to be when you put in 10 for this and 25 for that, that's going to give you 10 because that's 60 minus 50. This is 2 dy dx. We're good with dy dx being 2. That's the slope that you figured out in part B, right? So in part B, we already figured out that dy dx at 2510 is 2. So that's going to be 2 times 2 is 4, minus, we're putting in 10 for y. So that makes 20. And then over here, we're putting in 2 for this one. So that's 12 minus 2 is 10. And then that's all going to be over 60 minus 50 squared. So that's just going to be 10 squared. And hopefully you're starting to get the gist here that we're not going to really finish these out. You can if you want, but that would be sufficient for a free response answer. Any questions on A or B or C?
Mr. Baker,
Yes.
for C, if I just like all I did was plug in the numbers and like not even do basic multiplication, would they still take that?
Yep. As long as you don't have any variables left, you're good. So like you're saying, like you just did like 6
Parentheses 10.
times 10 minus 2 times 25, and it was all like nicely parentheses off and stuff. Yeah, you'd be
Yeah.
fine.
Okay.
Mhm. Okay, moving along. All right, here we go. I'm assuming lots of questions now. So it says, okay, water is pumped into a tank modeled by the equation such and such. All right, so this is referred to as, I call this an in and an out problem. You're going to see a lot of these throughout the year now. In and out. Something's coming in, something's going out. Something's increasing, something's decreasing. We're getting water in, water leaks out. Somebody stocks the shelves, people buy stuff. Something about 2 different rates of increase and decrease, in and out. So you'll hear me say, okay, this is an in and an out problem. All right, so water is being pumped into the tank, modeled by W of T, and we have an equation for that, but we'll come back to it. Here's the important thing. You want to just make a list for yourself, a little legend or a key or whatever you call it, saying what's what. W of T stands for in, and I'm even going to put in parentheses, that's the equation, just because it's easy to lose track of stuff. And we keep reading. Water is removed by R of T, that's the box up top. R of T, that's the out. So we have something for in, something for out. For out, we're going to say that's the box of data. Okay, we keep reading. Selected values from R of T are shown above. And there's also this other bonus piece of information just to throw you off. And at T equals 0, when this story begins, there are 32,000 liters in the, what are we talking about? In the tank, okay? All right, so before you do anything, make sure you got everything kind of situated in your mind. When you see an in and an out problem, this is the setup. Whatever they're talking about is kind of irrelevant, but something's coming in, something's going out, and there's usually some sort of starting piece of information. It could be water. I'm trying to think of other problems that come to my mind. There's a problem somewhere about bananas. Bananas were stocked on the shelf and then people bought them. Also, at T equals 0 when the store opened, this is how many bananas we had on the shelf, stuff like that. So you'll kind of see it's the same problem rewritten in various ways. Okay, just like every part A question that I've ever shown you guys, this one is no different. So when you're doing part A and it's asking you to estimate something with a derivative, it's just asking you to find the slope. So for part A, we are going to say that R prime of 6 is approximately equal to, and then we're going to pick the one where 6 would land, which is between 4 and 8. So it's going to be 900 minus 1100 over 8 minus 4. That's going to be negative 200 over 4. That's negative 50 liters per hour squared. Any questions on part A?
You could just leave it 900 minus 1100 over 8 over 4 meter, or what is it? Liters
Per hour
squared.
Yeah, you should be able to. The only reason I don't is everything I do is just based on the answer. So when it comes to free response, they release answer keys. And when I started teaching calculus, I just read them all. And then that's how I taught you guys. And for whatever reason, they always do the math on this slope. But based on the rules that they have laid out, I don't see why this wouldn't be accepted. On their answer key, though, they always hop to this answer. Usually it's just like trapezoidal sums, crazy quotient rule answers, stuff like that is where their answer keys, they're just left with a mess. This one, they usually do the math, but that said, I don't see how this is wrong because you can't pick and choose when those rules apply. So I think you'd be good either way.
Okay, I mean, I think they just wrote it out because of the next question.
That probably too, yeah. Okay, so part B is something new. You weren't supposed to get this whole test done correctly. I haven't taught you some of this. Part B, is there a time between 4 to t to 8 such that r prime of t is equal to negative 50? Explain and justify. What kind of problem do you think letter B is, guys?
Is it a mean value theorem thing?
That's exactly what it is. Good. Now he's got to figure out how to get credit for it. They ask mean value theorem usually once in the free response, and this is it. So good news. When they ask, is there a time? As far as I'm aware, the answer is always yes. I've never seen a problem where the answer is no. If they ask, is there a time, and it's a mean value theorem looking question, based on all of my research, the answer's always been yes. And then we just got to show why. So over 4 to t to 8, is there a time such that the derivative slope has to be equal to negative 50? So what did we find in part A? Just regular slope, right? So the regular slope in part A was 50. Okay, and we go up here, and then there's some calculus gibberish, some math gibberish you want to see. Here's the key word. It's differentiable. So we skip over a lot of these words whenever we're reading the free response just because we don't want to get overwhelmed. But they're always going to probably tell you it's something about it being differentiable. All right, if something's differentiable, 100%, I can guarantee you it's also what? Starts with a C.
Continuous.
Yeah, okay. And you're going to see that these problems always say it's differentiable. So to get full credit for part B, first off, our answer is going to be yes. Because the function is, now you're more than welcome to do all this abbreviating while we're learning over the last half of the year. You are not allowed to abbreviate in May when you actually take this. But for right now, yes, BC, the function is differentiable. 3 triangular dots means therefore, as long as you know what you're talking about, I don't care how you say it, but on the AP exam, write this out, is differentiable and therefore continuous by the MVT. There must be a time, I'm basically just rewriting the question. There must be a time where r prime of t is equal to negative 50 because, and then we just show the slope calculation after that, because 900 minus 1100 over 8 minus 4 is equal to negative 50. Let me turn this off so you can read all of that. Okay, yes, because the function is differentiable and therefore continuous, by the mean value theorem, there must be a time where r prime of t is -50 because, and we show the slopes. Now, that's easy enough to copy down. Let's also make sure you understand what it's saying, though. So, is there a time where the tangent slope is -50? Well, we already showed the average slope was -50. In part A, if you think about it, you don't need to show this, but just for your own understanding, in part A, we went from 4 to 8, and we figured out that that slope was -50. Will the regular slope normally be? No, I don't think that's ever going to be the case, Caroline. Normally they give you something completely different. That was a coincidence. So if the regular slope is -50, is there a time somewhere between 4 to t to 8 such that the tangent slope is also equal to -50? You should know, oh, you can't see that picture. You should know that answer to be yes, because that's the definition of the mean value theorem. It doesn't ask you to find the time, just says, is there a time? Is there a time from 4 to 8 where the tangent slope is equal to 50? And since the average slope was equal to, or -50, since the average slope is equal to -50, and the function is differentiable and therefore continuous, then this is getting to be messy calculus gibberish, but hopefully it kind of makes sense that yes, somewhere in there, that's got to be the case. That's going to pop up on the AP exam somewhere in a part B or something. So talk to me. Does that make sense? Kind of?
So that
Yeah.
makes sense, but because like the part A won't normally have the normal slope, how do we figure out, like, how do we prove that the slope's going to be there? Do we have to go through every single?
I got you. I think every problem I've ever seen, it's the end points of the problem, Caroline. So in the part B, it just happened to say from 4 to 8. So you would use the endpoints, use the interval they give you, and that usually usually shows you where you're trying to go.
Oh, okay, that makes sense. Thank you.
Even if you like 50% understand this, that'll be okay, because you're going to see this 10 more times in the second half of the year. This part B always pops up. Okay. So yes, because the function's differentiable and therefore continuous by the mean value theorem, there must be a time where r prime of t is -50 because, and then there we go. Okay. All right, on to part C. Use a left Riemann sum with 4 subintervals indicated by the table above to estimate the total amount of water removed from the tank during the 9 hours shown above. Is it an over or under estimate? We should be able to do that, no problem. So we know how to do Riemann sums. And it says for the data above to show how much water was removed. How do we figure out how much was going out? RT, the box, is the data for heading out that was being drained. So for part C, all we want to say is that the integral, because we're doing a total, right, of r of t dt from 0 to 9. Now, minor problem with this one. We need to do some math. We need to know this answer because let's read part D. Use your answer from part B to find the estimate for the total. That should say part C. Part B has nothing to do with it. From part C, use your answer from part C to find an estimate for the total amount of water in the tank. Hopefully it makes sense to you guys that the total amount of water in the tank was also going to involve the amount that was drained out. So we're going to come back to part D in a minute, but as far as part C goes, we actually need an answer here. So we're doing a left Riemann sum. So it's going to be equal to, we need some calculations. So it's going to be, the first one has a width of 1, and we're doing a left Riemann sum, so a height of 1400. And then the next one would have a width from 1 to 4 of 3 and a height of 1200. And we got to do 2 more, a width of 4 and a height of 1100. Last one is 1 by 900. So that's not the worst math in the world. So normal Riemann sum, you could just leave it. This particular problem, we need an answer. So that's 1400, 3600, 4400, 900. What do we get if we add all of that together? That fits together, right? That's 8, 9. I'm getting 10,300. Anybody else? And I'm going to call it liters. So let me turn this off again. Thoughts, comments, questions?
When we're doing normal Riemann sums and we don't have to answer it, should we still put the oh my god, what's the word? The
Units?
liters?
Yeah, always. So like say you were done here, you're just going to pretend that this line is the same exact thing as 10,300. So you would just tack a unit on right after it.
Great, thank you.
Okay. All right, next. Well, before I say next, do we have any other questions on that?
So is that the justification, or is the justification something different?
No, that's good. Your justification is just your math. And then there was also one more piece to this that said, is this an over or an under estimate? So let's go back and look at what we got. Is it an over or an under estimate? So it's it starts up high and it's going down low, right? So if you make a sketch, so see it starts at 1400 and then it drops. So if you picture that, I'm just running out of room here, but if you picture that, it starts up at 1400 and then it's going down. So if you do a left Riemann sum with that, what's it going to be, guys? Over or under?
Over.
It's going to be an overestimate, right? So if you do that, you can start to see that all of these would be over. So your answer is going to be, it's an over estimate because what is that function? R of t. R of t is a decreasing function, and something about we are or I am, we are using a left hand sum. Something like that would be full credit in my book. Okay. All right, so when you kind of take it back here and look at it in pieces, this is all super doable. Part A, you're getting super used to seeing. Part B is the first time we've seen it, but it's starting to click. You're going to see it a lot more. You're going to start to see a lot of repetition in these free response questions. They're very intimidating, in my opinion, at first, because it's just like, whoa, there's stuff everywhere. But once you do it 5, 6, 7 times, just with different problems, different wordings, different whatever, you're going to start to notice a whole lot of patterns, some sort of Riemann sum. What's the Riemann sum stand for? Write this stuff out before you start so you know what's what. You get 15 minutes on average per question. So time is not really an issue with free response. Time is an issue with multiple choice. 2 minutes a question, 30 questions, that's rapid fire. 15 minutes for free response, plenty of time. That just boils down to, do you know what you're talking about? Okay. All right, so let's take a look at part D. I'll go back for the official wording here in a second, but more or less part D is asking for the total amount of water at T equals, we want to know the total amount of water in the thing at T equals 9. So we just got to talk ourselves through the problem. There's 3 pieces to the problem. And those pieces are, what did I start with? How much came in? How much went out? If you put those 3 pieces together, you've got everything. So that's why I tell you to make a little legend before we start. How much did I start with? What's the total amount? Keyword, total amount. What does total amount tell me to do? Take a what?
Integral.
An integral, okay, of water in and then water out. So what would my setup be? The total amount. I like to make a function for it. I call it the amount function. So I'm going to call it A of t. The amount function is equal to 32,000 plus what? The water in, that's the integral of Wt dt from 0 to 9 minus the integral from 0 to 9 of R of t dt. Does that setup make sense? Here's what I started with, plus the total amount that came in minus the total amount that came out. What do we already know about this right here?
They give us the table.
They what?
Never mind. I thought I knew what I was talking about.
We
You
just
might.
found it out in the last part.
We just found it out in the last part, right? So I still need to figure out what's going on with water in, but I know that the water out is 10,300 because that's what I did in part C. So what I need to figure out this question is I need to go somewhere and figure out, all right, what's up with this integral from 0 to 9 Wt dt? Well, what do we know about Wt dt? Again, that's why I write this stuff down to begin with. It's the water in. We've got an equation for that. So we have an equation. So I'm going to just go way off to the side. And let's see, they tell me that W of t is equal to 300 t squared plus 600 t. Okay. Now, notice when I was writing my formula that I just called it W of t. There's no need to waste time copying all these formulas into your amount function. You can just abbreviate it with what the name of the function is. All right, anyways, we want to integrate this from, so I'm going to get rid of that, and I'm going to do that. I'm going to put an integral symbol there from 0 to 9. I'm going to put a dt so that it's mathematically correct. And we're ready to integrate. Is this an easy integration or a hard integration? Let me try that again. Do you need U substitution?
No.
Okay. Yeah, okay. Hard in the sense that these numbers are bigger than you want to work with. Easy in a sense that this is not U substitution. So I add 1 to the power and divide by the power. So this would be, just do it slow. Don't get intimidated by the big numbers. 300 t to the third over 3 plus 600 t squared over 2. That's really equal to 100 t to the third plus 300 t squared, bounds 0 to 9. Plug in the top minus, easy enough. They're both t's, 0 is going to be 0. So all we got to do is plug in the top. All right. 9 to the third, probably not your favorite idea. Sorry, you're in calculus, figure it out. 729. So 729, you're multiplying it by 100, so put 2 zeros after it. So 72,900 plus, what do we got next? That's 81 times 300. So all I'm doing, if I'm you guys, is I'm doing 81 times 3, and then I put 2 zeros on afterwards. This is doable. So that would be what? That makes a 3. That makes 24. And I just said 2 zeros after it. 24,300. Okay, we need to add that up. 72 and 24 is 96. 1,200 more. I'm getting 97,200. Did I do that right? Anybody confirm?
That's what I got.
Same thing. Okay. So that right there is the final result of this integral. So what do we do with it? We take it right here. 97,200. You can actually just leave that as your answer because now you've got everything filled in. You've come this far. I don't know. You might feel more satisfied if you get an actual answer. I don't know. That's up to you. At minimum, tack the word liters onto the end of it. What do we get if we do the whole thing? I don't know. Did anybody get this far? I wasn't expecting anybody to completely do this yet, but did anybody get here? So you're going to add 32 to that. So that's 9, that's 12, 129, 200. Take away 10,300. I'm seeing 118,900 liters. Okay. Yeah, Caleb, good. All right, guys, thoughts, comments, questions? Aside from the math being a little bit big, will you see numbers that large on the AP exam? I don't think so. This was a test that I had made, and I think I might have gotten my hair carried away with the numbers, but whatnot. Does the ideas make sense? Do we have any questions?
The ideas make sense. I have a question just in case the numbers are this big. Could you, like when we found what the integral was before we plugged in, which was 100t to the third plus 300t squared. Yeah, if we get that and we plug in 9 and, well, 0 just cancels out, could you just like put in parentheses, could you plug in 9 and then put that in parentheses and that could be your answer?
Yeah, yes. I believe so. Yeah, you're saying instead of 72,000, you're going to put in 100 times the quantity of 9 to the third?
Yeah, just
should be able to. Yeah, I don't think you're going to get anything this crazy, truthfully. I think this was a test that I made that I got a little crazy with, but they're normally much smaller than that.
Okay, thank you.
Okay. All right, let's see what else we got on here. Okay, so that's that problem. Takes us to the next one. Gene jogs. Okay, so what are we doing in part A? Should look really familiar. This problem's a breeze compared to the one we just did. What are we doing in part A?
Finding the slope.
Finding the slope. You should always be happy when you see part A. It's free points. Okay, part A. We are going to say that v prime of 14 is approximately equal to 200 minus 120 over 18 minus 10. We're going to say that that's equal to 80 over 8. We're going to say that's equal to 10, and then that's meters per minute squared. Should be able to do part A in your sleep. Okay, part B. Using correct units, explain the meaning of that. We should know it. And in the context of the problem, and then approximate the thing by using a midpoint approximation. That was that problem where we did midpoints, and I didn't really do that much with you guys, but we'll look at it. All right, what's the meaning? That's important. What is the meaning of the absolute value of v at t dt? Somebody?
It's
So
just the
just-
integral, but like a
Yeah.
positive one.
It is an integral. It is a positive one, but it has a specific meaning. The absolute value of v at t dt. It means something particular.
Is it the total distance?
The
Gee,
total distance. It's always total distance traveled. You might want to memorize that one. Write it down. Absolute value of v at t dt is the total distance traveled, and in this problem, in meters. And then they want us to approximate it. Okay, so we go right below it, and we're going to say the integral from 0 to 50, absolute value of v at t dt is approximately equal to, let's just do the midpoint approximation on the fly here. I'll show you guys how to do it. So you're looking for things that are the midpoint of something. So from 0 to 10, the midpoint is 5. So the width is from 0 to 10 is 10. But then you use the midpoint's height. So we're going to call it 100. And then we're going to go again. The next one goes from 10 to 26. Directly in the center of those two numbers is 18. So from 10 to 26 is 16. The height that corresponds to 18 is 200. And the last one is from 26 to 50 is a distance of 24. Its midpoint is 38. That is 150. And then we're just going to tack on the word meters after it and hope that we don't have to do any more math with that problem. Everybody good? Okay, part C. Robert's riding his bike along the same path for 0 to t to 10. Robert's velocity is modeled by such and such. Find Robert's acceleration at 5. We did a problem very similar to this. It was called Jeff jogs, now Gene's jogging. So this should sound pretty familiar to you. What do we need to do in this case? To find the acceleration given the velocity, what are we looking for?
Second derivative?
Correct, but what did they give us?
The first derivative. So we
Yes, I just need to derive it once, right? So we're going to say that Robert's velocity is given by b of t. So b prime of t is equal to 6t squared minus 6t. So then b prime of 5 is equal to that answer right there. If you want to stop, you can. That's what, 25 makes 150 minus, I'm getting 120. What are we talking about there? Meters per minute squared. Okay. Questions on C? Okay, what's the story for D? Average velocity. How do we do it?
You use the formula that you gave us, the average value formula.
You got it. What's the average value formula?
Do you want me to say it like with the
Mhm.
numbers plugged in?
No, let's just, yeah, sure.
1 divided by 10 minus 1 times the integral of 10 to 0 b of t dt.
Okay, and then I'm going to put that in. So 2t to the third minus 3t squared plus 200 dt. There's your setup right there. Now you need to go through and do that problem. Average value is 1 over b minus a times the result of the integral. Average value is 1 over b minus a, 10 minus 0. 1 over 10 minus 0 times the result of that integral. So you're going to integrate this, and this would be 1 over 10 times, when you integrate that, that's t to the 4th over 4. So t to the 4th over 4 with the 2 is just half. So that's half t to the 4th minus 3t to the 3rd over 3 plus 200t from 0 to 10. Plug in the top minus plug in the bottom. Bottom's going to be 0. We put the top in, 10 to the 4th. 10 squared is 100. To the 3rd is 1,000. To the 4th is 10,000. 10,000 times a half, 5,000 minus 1,000 plus 2,000. Bring our 1/10 down. You could technically stop there, but we've come this close. That's 5,000, 4,000, 6,000 times 1/10. The answer to the question was 600.
Do you need units for this one?
No.
Okay.
Questions, guys? Just need a little more practice, but the ideas are starting to look familiar. That's the goal. Okay. All right. That is going to be it. I need you guys to stick around for 1 minute. Bennett, you can turn the video off. We're going to